Hello all, I'm Professor Hina Panjwani from Ahmedabad Institute of Technology. In this tutorial, you will learn about what is asymptotic notations are. Fine. So, asymptotic notation is what? The efficiency of an algorithm depends on the amount of time storage. I already discussed about time factor and space factor. These two factors are uh, for our algorithm. So efficiency of an algorithm depends on the time, storage and other resources required to execute the algorithm. The efficiency is measured with the help of asymptotic notation. An algorithm may not have the same performance for different types of inputs. See, your inputs are different, so performance is also different. Like मैंने जैसे बताया कि 100 मेरा इनपुट होगा, तो रनिंग टाइम उसके लिए अलग होगा. 1000 मेरा इनपुट साइज होगा, तो उसके लिए रनिंग टाइम डिफरेंट होगा. Fine. So asymptotic notations are the mathematical notation used to describe the running time of an algorithm when the input tends towards a particular value or limiting value. Example ले लेते हैं. For example, bubble short. When the input array is already shorted, means 1, 2, 3, 4, 5. Here I am taking an example. So here input is already shorted. So if I want to search 1 from this list, so this is already sorted. So फर्स्ट नंबर पे ही मुझे मेरा जो डिजायर्ड एलिमेंट था वो मिल गया. ठीक है. तो ये वाले केस को हम क्या बोलेंगे? बेस्ट केस बोलेंगे. कौन सा केस बोलेंगे? बेस्ट केस. देयर आर 3 केसेस: बेस्ट केस, एवरेज केस and worst case. So in bubble sort, when array is already sorted, the time taken by algorithm is linear. So this is my best case. But when the input array is reverse condition, means 5, 4, 3, 2, 1, the algorithm takes the maximum time to sort the element. इसको मुझे शॉर्टेड करना हो तो अल्गोरिदम क्या लेगा? मैक्सिमम टाइम. सो दिस इज माय वर्स्ट केस. फाइन. when input array is when input array is neither sorted nor in reverse order, so in which case? Average case. How? When input array is neither sorted nor in reverse order. That means suppose 1, 5, 2, 7, 9. See, I am taking just ऐसे मैं एग्जाम्पल एक ले लेती हूँ कि 5 मेरा शॉर्टेड है, एवरेज मतलब इस पे है, और दिस साइड लेफ्ट साइड सारे मेरे क्या है? 5 से स्मॉलेस्ट एलिमेंट है, और राइट साइड ग्रेटर एलिमेंट्स है. सो जस्ट मैं ऐसे ही बताना चाह रही हूँ कि मिडल में मुझे एलिमेंट चाहिए कोई सर्चिंग के लिए, तो वो मेरा जस्ट क्या दिखा रहा है? एवरेज केस दिखा रहा है. फाइन. सो दीज आर दी केसेस: बेस्ट केस, वर्स्ट केस, एवरेज केस. फाइन. सो in asymptotic notation there are 3 notations: theta notation, omega notation and ziggo notation. Let me just show you. I am here showing. I have to draw graph n0, This is my f of n. This is my c star g of n, and this is n. Right? So for big O notation, f of n less than or equal to c star g of n. Fine. See, n0 and c are two integers, constant, c constant, and for all n greater than or equal to n0. See, I am taking one example. F of n is equal to 2n plus 2. My function is what? F of n is equal to 2n plus 2, and g of n is equal to n square. I have to prove that f of n less than or equal to c star g of n for upper bound. Big O notation, that means वर्स्ट केस आपका जो होगा ना वो दिखाता है. So if I am taking n is equal to 1, so what is the value? Putting here in f of n 2 into 1 plus 2, because I am taking n is equal to 1. So 2 plus 2, 4. So f of n is equal to 4. Same likewise, g of n is equal to n square. That means g of n is equal to 1 का square क्या होगा? 1. Fine. So in this condition, f of n मेरा बड़ा है g of n से. You can see here clearly. ठीक है? But we have to prove f of n is less than or equal to c star g of n. c star g of n मेरे को ऐसा कांस्टेंट लेना है कि मेरा क्या होना चाहिए? g of n जो है वो बड़ा होना चाहिए. If I am taking n is equal to 2, लेके देखो तो f of n 2 into 2 4 plus 2 क्या होगा? 6 होगा. ठीक है. And g of n 2 का स्क्वायर क्या होगा? 4. Fine. Again in this case f of n greater than g of n. If now I am taking n is equal to 3, then what? 2 into 3 plus 2, that means 8. So f of n is equal to 8, and g of n square, that means 3 का स्क्वायर क्या आएगा? 9. ठीक है. So in this case f of n less than g of n is true. So we can conclude that for n greater than 2, we obtain f of n less than g of n. Fine. So always upper bound of existing time is obtained by big O notation. In later tutorials, we can learn about omega as well as theta notation. Fine. Thank you for watching my video.